Pharmacokinetics of T catechins after ingestion of green tea and epidemiol 3 gallate by humans, formation of different metabolites and individual variability. Green tea and tea polyphenols have been studied extensively as cancer chemopreventive agents in recent years. The bioavailability and metabolic fate of tea polyphenols in humans, however, are not clearly understood. In this report, the pharmacokinetic parameters of epidemiol 3 gallate, EGCG, epidemiol EGC, and epicatechin, EC, were analyzed after administration of a single oral dose of green tea or decaffeinated green tea, 20 mg tea solids per kilogram, or EGCG, 2 mg per kilogram, to 8 subjects. The plasma and urine levels of total EGCG, EGC, and EC, free plus conjugated forms, were quantified by HPLC coupled to an electrochemical detector. The plasma concentration time curves of the catechins were fitted in a one-compartment model. The maximum plasma concentrations of EGCG, EGC, and EC in the 3 repeated experiments with green tea were 77.9 plus or minus 22.2, 223.4 plus or minus 35.2, and 124.03 plus or minus 7.86 nanograms per milliliter, respectively. And the corresponding AUC values were 508.2 plus or minus 227, 945.4 plus or minus 438.4, and 529.5 plus or minus 244.4 nanograms by HXml, -1, respectively. The time needed to reach the peak concentrations was in the range of 1.3 to 1.6 hours. The elimination half-lives were 3.4 plus or minus 0.3, 1.7 plus or minus 0.4, and 2.0 plus or minus 0.4 h, respectively. Considerable interindividual differences and variations between repeated experiments in the pharmacokinetic parameters were noted. Significant differences in these pharmacokinetic parameters were not observed when EGCG was given in decaffeinated green tea or in pure form. In the plasma, EGCG was mostly present in the free form, whereas EGC and EC were mostly in the conjugated form. Over 90% of the total urinary EGC and EC, almost all in the conjugated forms, were excreted between 0 and 8 hours. Substantial amounts of 4-pheto-methyl EGC, at levels higher than EGC, were detected in the urine and plasma. The plasma level of 4-pheto-methyl EGC peaked at 1.7 plus or minus 0.5 hours with a half-life of 4.4 plus or minus 1.1 hours. 2-ring fission metabolites, -5, 3, 4 feet, 5, trihydroxyphenyl, gamma-valerolactone, M4, and -5, 3, 4, dihydroxyphenyl, valerolactone, M6, appeared in significant amounts after 3 hours and peaked at 8 to 15 hours in the urine as well as in the plasma. These results may be useful for designing the dose and dose frequency in intervention studies with tea and for development of biomarkers of tea consumption.